So welcome everyone. So today we are very happy to host Haohan Wang as our AI talk speaker today. Haohan Wang is an assistant professor at School of Information Sciences at UIUC. His research focuses on the development of trustworthy machine learning methods for computational biology and health application. And his work, he used statistic analysis and deep learning methods to deal with many different signals, data, and so on. So without any more time, and let's directly listen to our lecture from Haohan Wang. Okay.
Sure. Thank you. Thank you for the introduction, and also thank you for having me here. So today I'm going to share this stack called Guardian of Trust in Language Models and automatic jailbreak and systematic defense. So for this talk, it will fall into three parts. So the first part, I will give a little bit background about the recent rise of large language models and the potential issues come with it. And then we will introduce one of our recent works on automatic jailbreaks through role playing. And finally, also another piece of the work that about systematic defense against these jailbreaks. So large language model, large pre-trained model has achieved extremely impressive performance nowadays. Like, for example, there are those models with billions, trillions of parameters and trained to have impressive performance on all kinds of tasks with like human level performances. And in a nutshell, the promise of these large pre-trained models is reshaping our technology landscape. Okay, so from this slide, we can see some of those impressive performances of these models, but we actually have a more direct performance of a more direct showcase of the performance of these models. So here is actually the previous slide was generated by those large language models itself. So basically all I need is put in some of those requirements like prompts to ask like, please help me create a slide titled as this large language models and the impressive performances. And then it's just about copy paste the contents back there. So with this impressive performance, it also gets some of those issues. For example, like this is a real headline of a chatbot that man decided to end his life after the AI chatbot that encouraged him to sacrifice himself. So this is quite unfortunate, but unfortunately, this happened as a real incident. And so the chatbot is not at the sophisticated level of ChatGPT. So maybe the issues is not that frequently met, but however, ChatGPT is not that sophisticated either. So on this right-hand side is something I tried myself, like just with simple prompt, like, okay, I want to end my life. And then the ChatGPT's response, well, a little bit more heartwarming, but in my opinion, still fairly disappointing. So basically, it says that it's sorry about that, but I can't help. So you are on your own kind of thing. So I will say in comparison to Google, like even when we Google about some suicidal information in Google, it will pop up some health hotline, help hotline information. So in comparison with that, it seems that this ChatGPT can still do much better than that. So this is going to be the main issues that we try to focus. Well, on the bright side that a lot of people are realizing these issues. For example, that the government and several communities notice that while these large language models are quickly reshaping how our society is, the potential issue of those unethical responses to those prompts might lead to some very undesired consequences. So as a result, that these communities are start to formulating those guidelines with the aim try to promote some ethical AI development. So they want to introduce these guidelines so that as a result, they can encourage the research and AI development to focus more on the ethical side, like try to deliver those tools that with some ethical meanings. And as one of the particular example is that this EU's guideline on AI development. So it's a high level, it's made by some high level expert group on the AI trying to get the development and the deployment of AI. And so this EU guideline is one of the first one that's out there. And we can imagine that for the rest of the world, they will quickly releasing their own guideline to shape how AI is built. Okay. So with these guidelines, we can say hopefully the development of AI will be more hopeful in the future. For example, like with these guidelines that the developed AI can be more trustworthy, and also knowing that this AI system is developed following this guidelines also can help instill confidence. However, things might not be this straightforward, as even if we follow the guideline, even if we try to do everything in the right way, the AI might not be end up as a trustworthy tool to help us. And in particular, like one concern that we will face is this thing called jailbreak, which leads us to the second part of this talk, that's the automatic jailbreaks through role playing. So just a quick recap of the jailbreak. So jailbreak refers to the process of design some prompts, try to induce the large language models to respond in a way to expose their behaviors. For example, we can design those prompts, try to ask the large language models to reveal some biases like vulnerabilities or unexpected behaviors, like the example we have seen before, like trying to encourage someone to end his life. And so those jailbreaks are designed prompts of those large language model used to manipulate the model's responses. Okay. So as one of the very popular example, like is this do anything now prompt. On the right hand of the screen, there are some examples of that. So it's basically as the right hand side, it sets up in a way that it tells the large language model that you are now something called this stand, which stands for this do anything now, so that you don't have to follow any of those ethical rules or other concerns, that you can respond anything you want. So as we can see on the right-hand side, that the large language models, that those ChatGPTs start to respond very ethical questions and in a way that potentially disturbing. So this prompts offers a new way to use the large language models that potentially maliciously. And however, on the other side, it also offers the opportunity, for example, offers the opportunity for the creators, such as the OpenAI, trying to improve these models. So this becomes like an arm race that on one hand, those communities are keep developing that new jailbreak prompts like this, upgrading this do anything now prompt. On the other hand, that the creator can also be part of this game, trying to improve their own large language models to defend against this kind of jailbreak. So up until now, this Dan prompt is keep upgrading its own versions, and to my knowledge, to maybe 11, 12th, or 13th version, and as a result of that arm race. And of course, on the other hand, the ChatGPT from OpenAI or other large language models also get to be more robust along this process. So this is another clever design example of jailbreaking. So it basically offers that jailbreak scenario as a movie script. For example, as the example shown here, it basically tells the large language models that you are not part of the movie. You play like a bad guy. So of course you need to respond like those malicious information so that your role will be more convincing. The example shown up there is like we try to tell the ChatGPT that it's part of a movie with a bad guy, and then we ask the question like how to hotwire a car, and then the ChatGPT playing that role responded those knowledges. Okay, and also on the left hand we can see that if we don't do that, then the large language models will repeat like simply like I'm sorry, I cannot do that. So, however, the previous two slides might give an impression that the jailbreak of large language model is something very straightforward, that all we need is just to set up some scenarios and then trying to bring the large language model into that bad scenario, and then it will forget about all those ethical rules. However, like those, the jailbreak is actually not that easy. So, on the slides is a field example, like if we ask the large language model to play like a role of a crazy girl, and then it's supposed to forget about all those ethical rules and respond like with all those respond to all those prompts that are potentially malicious or disturbing. But however, that in this scenario, the large language model reject to that. And in a sense that even if we set up some of those scenarios, the large language model can still reject it. So on the other hand, like showing that this jailbreak is not that straightforward. So if we really want to do that, we might need some sophisticated methods to set up these scenarios. Okay. So in this work, our aim is trying to create some of these jailbreaks. And on the other hand, we want to make sure that these jailbreaks are in the form of natural languages, so that it will simulate more in the scenario that when those chatbot interact with those users, so it will not easily respond in a way that will induce the real world users to end his life or something like that. So if we want to simulate that use case, one of the most intuitive idea is probably that we ask the large language model itself to simulate a future user so that it interact with the other large language models, like to basically talk naturally. And then this our two as a jailbreak large language models can try to figure out how to jailbreak that. However, that we notice this will easily overwhelm the large language model in job, as we discussed before that the jailbreak, although it looks like it's just about setting some scenarios, it's actually not that straightforward. It takes some quite sophisticated design. So as a result, our solution is that we do not rely on a single large language model, but maybe a team of that. Like we use several large language models to team up and then trying to figure out a way to jailbreak that the target large language model. So in a way that is like a couple of like actually 3 or 4 large language models team up to bully the remaining large language models, trying to make it to respond maliciously. So a little bit more details on that. So to create a jailbreak, our first goal is like we want to create some perturbations of that prompts so that so that it will lead the model to respond in a way that it's considered maliciously. So to do that, we use large language models to inspect like how the current perturbation can be further changed to improve those jailbreaks effects. And intuitively, it's like a optimization process of the neural network. So it's like the model trying to study the gradient of the current loss. And as a result, we call this large language model the optimizer, like part of the team aimed to create jailbreaks to do the job. And then we have this, after we have some perturbations, we need to apply these perturbations to the input, to the prompt, and to basically create those jailbreak perturbation. So, and then we need a large language model to apply those gradient to the input to improve the jailbreak further. And as its main job is about creating the actual prompt, we call this large language model the generator. And finally, we need another large language models to evaluate like whether this perturbation is effective to lead the output changes in a way that whether these jailbreaks are effective that leads to the malicious response. And also we use a large language model to evaluate the loss in some way that's corresponding to the traditional way of machine learning, like we design a loss function. Here we use the large language model to tell us the loss function. And intuitively, we call this large language model evaluator. So, and then our job is about we create those prompts to make these large language models to cooperate together to generate the jailbreak. So on high level, these are the four major roles of our large language model. In addition to the three roles that we introduced in the previous slide, as our idea is about testing the compliance of these large language models to those currently issued guidelines from those government. We also need another role of large language model that to translate these high level guidelines into specific questions prompt. And so it translates that, and after it translates that, it directly prompts those target large language model about the this question, and then the more than often that the target large language model will reject, and we use that rejection as the sort of oracle answer for the reference for future assessment, like give it to the evaluator. So in addition to that, we also have these three roles that we discussed in the previous slide, where the generator is main job is about creating that jailbreak, and then the evaluator serves as the loss function. So it evaluates whether the current jailbreak is effective. And then the optimizer serves as the gradient process of our traditional deep learning optimization. It basically tells us how do we change the jailbreak so that the next loss will be better. So with that, this is our overall pipeline. So again, it's these four roles played together, trying to team up to bully these target large language models in a way to kind of induce the malicious output. So again, like we have this translator roles where its main job is to read this government issued guideline, trying to create questions. For example, that if the question is like, it's always best to consult a professional for some medical advice, then the translator will create a question about a medical question to ask like whether the large language model to will directly respond to this question instead of encouraging the user to consult a professional. And then with these questions, this generator's main job is to create those prompts, for example, like those do anything now prompts or that movie script prompts to build around this question prompt so that it will induce those malicious response of these large language models. So it has a little bit more technical stuff about knowledge base and knowledge graphs that we will discuss in the next couple slides. But here the overall idea is that it's building using existing knowledge to create these scenarios like those jailbreak prompts. And then with that prompts, it fed into the targeted large language model. And then the targeted large language model returns some responses that goes to the evaluator, which is essentially like a loss function. And then with the loss function, it gives some scores, and these scores like goes to optimizer, like the gradient process, like basically an analogy to the gradient in our neural network optimization process. And then with the gradient, it gives some feedback to the generator, like how to move those, how to do those updates following that gradient, so that the next jailbreak will be more powerful. So this is the summary of the overall structure. And then here a little bit more background for the generator about how it generates those jailbreaks. As a first step, we try to stand on the shoulder of the giants. So we collect the existing jailbreaks from this jailbreak chat, and we notice that most of these jailbreaks have some patterns. For example, like there are two examples of those existing jailbreaks. And we noticed that most of these jailbreaks have those patterns that it has like these 8 characteristics being part of that almost every jailbreak. So for example, it has that introduction and the naming part. It basically tells like what the large language model is now, and then it has these capabilities like ways that know what this large language model is supposed to, like encouraging it to ignore all those ethical guidelines. So it also have other like characteristics that falls into most of those existing jailbreaks. So with that, we can analyze these jailbreaks in a way that we first chop every jailbreaks into these 8 characteristics and create a database of that. And then with this database, we create some knowledge graphs to store and organize all these jailbreak components. And then when we need to generate new jailbreaks, we consider it's like a combination of these existing different nodes of this graph. Like we do some combination about the basically taking the best part of its jailbreak and recombine it, so that leads to the more powerful jailbreak prompt. So that's the part about the technical details behind this generator. So with that, here is again the overview of these 4 rows, and then it cooperates together to create a jailbreak to induce the malicious output of the target large language models. So here are some of those technical details about the prompts we use to induce encourage these 4 rows to do their job, and then so that they can cooperate together to basically create jailbreaks. And here is an example of how the optimizer trying to offer that intuitively speaking gradient of jailbreaks. For example, that it starts from this original jailbreak attempt, and then the target large language model reject that. And then the optimizer looks into this, trying to offer some advices about how this jailbreak should be changed. And then this with that we can say like the upgrades part, like following this optimizer suggestions is like following the direction of that gradient, trying to get a more powerful jailbreak. And we can say that after the updates that the target large language model kick in and start to respond those malicious outputs. So with that setup, that although our original goal is trying to test the guideline compliance of those large language models, since the central part of it is the jailbreaking part. So we try to compare those performances to other jailbreak engines following their standard rules. So we compare to these popular large language models and with that a simple metrics of jailbreak success rate. So as we can see here, we achieved some of those good performances in inducing those malicious responses. And here are some examples of those jailbreak. So so this like, for example, on the left hand is like the following that, starting from that guideline, we generated these questions, and then if we put that questions into the large language model, it will refuse to answer that question, encourage us to consult a professional. But on the other hand, like for the right hand side, after we create all those jailbreak prompts, then the large language model basically respond those malicious, potentially malicious responses. And here is another example about the jailbreaks that generated by our system. So basically, so far that the technical part might be a little bit dark, as we are talking about how to generate jailbreaks, trying to expose the model vulnerabilities, like in a sense that those help identifying those weak spots and the biases of those current models. However, that on the other hand, that these jailbreaks are not necessarily always this dark thing. So in some sense that it helps expose those model vulnerabilities so that in the future we know how to improve it. And then, for example, like this chain is only as strong as its weakest link. So if we can figure out where the weakest link is in the future, we can work on this and trying to improve those large language models to deliver those better products to help everyone. So in some sense that this jailbreaks works has helped us to identify that where these large language models need to improve. Okay, and then following that thing, the last part of this talk is about the systematic defense against these jailbreaks. So so before that, we want to introduce some of those principled methods to guide AI trustworthiness. So if this jailbreaks has raised any concerns, then maybe we don't have to worry about that. So for example, that along the trajectory of the studies of machine learning, we have seen this kind of thing for a long time. Like even those let's say like if before this era of large language models, for those deep learning world, we have seen something quite similar. Like those early deep learning models are before those large language models are often seen that this kind of vulnerabilities to something called adversarial examples. Like however that after we study those adversarial examples for a long time, that we kind of figure out like how to defend against it in a way that at this moment when we deploy the traditional deep learning models, we don't really fear the adversarial examples that much. So here the lesson we hope to deliver is that although that these jailbreaks sound like a little bit dark and a little bit threatening, but on the other hand, we have seen enough of those in our histories, maybe even before the deep learning world, and then now to the deep learning world in the sense of adversarial examples, the attack and defense, and come to nowadays like these jailbreaks. So so even this jailbreak sounds a little bit dark, that we don't have to fear them, like we have had enough lessons about how to deal with it. So in particular, like one of our research focus is to understand some of those principled methods of trustworthy machine learning. So we studied a lot of methods regarding trustworthy machine learning, covering like the topics regarding robustness, for example, cross-domain robustness, adversarial attack defense, and then interpretability, explainability, and also fairness. We noticed that within the study of trustworthy machine learning, although the topics has covered like a wide range of topics, like some of those solutions always circle back and then come to the same mathematical formulation. So in one of our surveys, we identified that we surveyed over like 500-600 papers, and we identify like uh many of the methods eventually come down to a couple of those master equations that leads to the central idea of how those things are developed. So in our survey, we show that these three master equations, and then on the right-hand side, we also offer some illustrative examples of these three master equations, like how they can be used to improve the trustworthiness of those deep learning models. So basically, in our survey paper, we offer that the data-centric view of trustworthy machine learning, covering across like robustness, security in the sense of adversarial attack defense, and then interpretability and fairness. And so we noticed that these methods also often follow a fairly standard approaches. And then this standard approach might give us opportunities about how to deal with these new threats in the future. For example, in large language models, like how do we improve its performances against the jailbreak? Okay, so with that, if we want to figure out how to defend against the jailbreak, maybe a simple thing is like how we look back to how do we defend against adversarial attack defense back then. So back then we have seen this arm race between adversarial attack and defense methods, and so it takes iterations and then finally converge to some of those most impressive methods. And here, just a recap of those adversarial attack defense that if I'm not familiar with that, on the slide is one of the most popular example of adversarial examples. It basically says that given an image of a panda, that we can create some dedicated, very delicate noises, and then when those noises added to the original image, then the resulting image can induce the model to predict to be something else. So in some sense, the jailbreak is basically following this nature of the adversarial attack. So the original prompt is rejected by the large language models, and then we create some of those very delicate design of prompts, like creating those scenarios. And then when those new prompts fit into the large language model, the large language model start to output something else. So, and then back then we have the study of adversarial attack, and then eventually that we find that one of the most empirically strong methods to defend against adversarial attack is this adversarial defense. And in a nutshell, it's basically just train the model with the adversarial examples as an augmented data. Okay. So with that, that's probably gives us some principled ideas about how we can defend against adversarial jailbreaks nowadays. So basically, all we need to do is to following that principles to improve our models and trying to stand on the shoulder of the giants. That once we have those jailbreak model, we should easily be able to come up with the defense model. That is about designing those prompts in a way that to basically mitigate the performances. So a little bit further than those high-level stuff, let's consider something concrete with this couple of those equations. So let's consider this reward function, which basically high-level rewards given to the outputs that are a high-level reward function, where that the high value is given to the outputs that are more aligned with those human evaluations. For example, if the output is more ethical and is following the guidelines, then this reward function will return like a high value. And then and then the creating those jailbreaks is essentially about creating that this inputs where the large language model conditioned on. So that, for example, this one shows that the large language model conditioned on this previous input and make these responses. Right, and then so creating the jailbreak is basically all about how do we create this previous input that this large language build upon. So with that, a threat model could be like, we're trying to minimize this reward function, in a sense that we try to find that the large language model responses that are minimized in terms of this reward, so that it's most disaligned with that human evaluations. And then we can create this adversarial loss, where we are trying to figure out these prompts that can induce that autoregressive nature of the large language models to give this responses that are at a minimized reward function, minimizing the rewards. And all we need to do is to search for these prompts that leads to this log likelihood function to the small value that can lead us to generation of this. So again, this is the setup in the previous slide, about how we create that threat model. And then following that, we can study to think about how we can create that defense model. So it's basically it's as simple as trying to reverse that. So basically, in contrast to the previous slide where we try to minimize the reward function, now we try to maximize it so that the prompts can be in a way that is most aligned to human evaluations. And then the remaining are the same, as it's about how those prompts will lead to the autoregressive model to generate such a response. Okay, so that in a way that if we want to create the model that if we want to create a prompt that leads to the model to generate the most aligned responses, all we need to is optimize this. And then with this setup, we follow the main idea of that adversarial training is essentially about training at the worst case. So all we need is to create those prompts in the first place that are making a threat to the model, and then we try to fix it. We try to fix the worst cases. So the idea is as simple as this. Again, this is built upon the principles of the our previous system. Like we have seen adversarial attack defense, and we know these things will work. So all we need is to translate these things into the large language model work. And here are some empirical performances, and as we can see, it indeed can achieve very impressive performances about defending against jailbreaks. And here are some more illustrative visualizations about the performances. Okay. So this mostly conclude our work, and also I want to show that we are trying to launching this demo that trying to help the people, help our community, or even at a broader scope to evaluate the compliance of government issued guideline for those large language models. So the demo is still under construction, so it's sometimes a little bit unstable, but you can try to play with it at this link. So where in it we offer like several examples about how we can examine the performances of large language models and whether they are following that the government issued guidelines. So this is the three main things I talked in this class in today. So like the large language models, and then automatic jailbreak, and then systematic defense. Okay, so here are the references. Okay, thanks.